Hello, I'm Maurice Dupre, and in this section we're going to discuss derivatives of trigonometric functions. Remember, the basic trig functions are sine, tangent, and secant, and their co-functions, the cosine, cotangent, and cosecant. There are just 6 of them, and we want to know how to differentiate each one. To begin, let's look at the sine. The derivative of the sine function is the cosine function. In other words, d over dx applied to sine of x is cosine of x. Well, what about the derivative of the cosine function? The derivative of the cosine function is the negative of the sine function. So d over dx applied to cosine x is negative sine x. So remember now, derivative of sine is cosine, but derivative of cosine is negative of sine. What about the other trig functions? Well, let's look at them all together and try to see the pattern. Derivatives of the trigonometric functions. The derivative with respect to x, again, of sine x is cosine x. The derivative with respect to x of cosine x is negative sine x. The derivative with respect to x of tangent x is secant squared x. The derivative with respect to x of cotangent x is negative cosecant squared. The derivative with respect to x of secant x is secant x times tangent of x. The derivative with respect to x of cosecant x is negative of cosecant of x times cotangent of x. So notice here are the basic trig functions, sine, tangent, and secant, and here are their co-functions, cosine, cotangent, and cosecant. Remember, the relation between a function and its co-function in trigonometry is that if I take the sine of pi over 2 minus x, I get the cosine of x. And so consequently, differentiating the cosine of x is differentiating the sine of pi over 2 minus x. And so that minus x is going to give a negative sign through the chain rule and differentiation. And so consequently, that's why these negative signs are appearing over here in front of the derivatives of the co-functions. So for instance, the derivative of the tangent is secant squared. Well, the derivative of cotangent has the exact same form. It's cosecant squared, but this negative sign is in front. Derivative of secant of x is secant times tangent. The corresponding formula for cosecant of x just replaces each function there with its co-function. Derivative of cosecant x is cosecant x times cotangent of x with this negative sign in front again. So you see, to get the formula for the co-function, just replace each function with its co-function in this left-hand list, and then we could get the right-hand list, except we have to remember to put the minus signs in front. Well, let's use these rules of differentiating trigonometric functions to differentiate some functions involving trig functions. Well, to begin with, I want to differentiate the tangent of x. Now remember, our formulas tell us that's secant squared of x. But let's look at the fact that tangent of x is actually sine x over cosine x and apply the quotient rule for differentiation and see what we get. We know that the derivative of sine is cosine and the derivative of cosine is negative sine, so it'll be easy to apply the quotient rule. So let's begin by differentiating the numerator. The derivative of sine is cosine of x, and then multiply by the denominator. Minus, now copy the numerator, sine of x, and multiply by the derivative of the denominator. Derivative of cosine x is negative sine x. And divide by the square of the denominator. So that's a cosine squared x. Now cosine x times cosine x is cosine square x, minus sine x times negative sine x is plus sine squared x, all divided by cosine squared x. And so from our basic Pythagorean identity for the trig functions, cosine square plus sine square is 1. So this is 1 over cosine of x, quantity squared. And now 1 over cosine of x is secant of x, so we get secant of x quantity squared, which we write secant squared of x. So in effect, we can easily derive the formula for differentiating tangent of x from the fact that tangent of x is sine over cosine, and just remembering what the derivatives of sine and cosine are. So if you happen to forget, if you can remember the basic ones to start, then you can get the derivatives of the other ones. For instance, to differentiate the secant of x, just use the fact that secant is 1 over cosine. Let's use our differentiation rules and our formulas for differentiating the basic trig functions to differentiate functions involving trig functions. Here I have y equals the cotangent of x divided by the quantity 1 plus cotangent of x. So to differentiate, let's use the quotient rule. I'll begin by differentiating the numerator. The derivative of cotangent x is negative cosecant squared of x. We multiply that by the denominator. We put a negative sign, and now let's copy the numerator, that's cotangent of x, and multiply by the derivative of the denominator. Well, the derivative of 1 is 0, and the derivative of cotangent x is again the negative cosecant squared of x. All this is finally divided by the square of the entire denominator. Well, let's just simplify this a little bit. Negative cosecant squared x times 1 will simply be negative cosecant squared x. And then negative cosecant squared x times cotangent x, well, that's simply negative cosecant squared x times cotangent of x. There's no simplification that we can do there. And now for this term, we have negative of cotangent x times negative cosecant squared x. That will be plus cosecant squared x cotangent x. And we're still all dividing by 1 plus cotangent x quantity squared. Now look what's happened. Negative cosecant squared x times cotangent x plus cosecant squared x times cotangent x. These two terms are canceling. The only thing that survives is the leading term, negative cosecant squared x. All that's divided by the quantity 1 plus cotangent of x quantity squared. Let's differentiate a function involving trig functions as well as powers of x. Here I have y equals x squared times sine x plus 2x times cosine x minus 2 times the sine of x. So we're going to be using the sum rule and the difference rule, and then on each term we simply use the product rule. Okay, so the derivative of y with respect to x equals, starting on the first term, we have to apply the product rule. The derivative of x squared is 2x times the second factor sine x plus x squared times the derivative of sine x. Well, that's cosine x. Now for the second term, it's a factor of product of x with cosine x with the coefficient 2. So we'll have plus 2 times the derivative of x, which is simply 1, times cosine of x, plus 2x times the derivative of cosine x, which is negative sine x. And then finally minus 2 times the derivative of sine x, which is cosine x. Well, let's see. Do we have any cancellations? Look, 2x sine x and 2x times negative sine x, those are the same thing except for the sign. They cancel each other out. Here I have 2 times cosine x minus 2 cosine x. These are canceling out. So finally, the only thing that survived is the x squared cosine x. So we have dy dx equals x squared cosine x as our final result. Well, we sometimes have to deal with exponential functions along with trig functions. Remember, the exponential function is easy. The derivative of e to the t is e to the t. It's its own derivative. Well, let's look at an example. Here I want to differentiate s equals tangent t minus e to the negative t. So all we do is differentiate each term. ds dt is derivative of tangent t, that's secant squared of t, minus the derivative of e to the negative t. Well, the derivative of e to whatever is just e to whatever, multiplied by the derivative of what's up there in the exponent, the whatever. And so consequently, the derivative of negative t is simply negative 1. So we get finally secant squared of t minus a minus is plus e to the negative t as our answer. Well, let's look at another example. Here I have the expression r equals 4 minus theta squared sine theta. Let's calculate dr d theta. So dr d theta equals, well, the derivative of 4 is 0 minus, and here I apply the product rule. Derivative of theta squared is 2 theta times the other factor sine theta plus theta squared times the derivative of sine theta, which is cosine theta. So here I have the final answer. Dr d theta is simply the negative of 2 theta sine theta plus theta squared cosine theta. Here in this example, we have r equals secant of theta times cosecant of theta. So what is dr d theta? Just use the product rule. The derivative of secant theta is secant theta multiplied by tangent of theta. And we multiply that by our second factor, cosecant theta, plus secant of theta multiplied by the derivative now of the second factor, that's negative cosecant theta times cotangent theta. So there we have the derivative now of r equals secant theta cosecant theta, and we could take out the parenthesis, secant theta tan theta cosecant theta minus secant theta cosecant theta cotangent theta. If you wanted to, you could factor out the secant theta cosecant theta and express this as secant theta cosecant theta times the quantity tangent theta minus cotangent theta. Let's look at an example of a limit involving trig functions and exponentials. Here I want to compute the limit as x approaches 0 of secant of this enormous quantity here, e to the x plus pi times the tangent of the quantity pi over 4 secant x minus 1. Well, that looks like almost like a nightmare, but all we have to do is look and see where everything's going as x approaches 0. Let's look inside. As x goes to 0, e to the x goes to e to the 0. E to the 0 is 1, and so we'll have 1 minus 1, and it's gone. So in effect, as x approaches 0, we can forget the e to the x and the negative 1 here. Let's look at this middle term. As x goes to 0, secant of x goes to secant of 0, and secant of 0 is 1. So this whole expression just becomes pi over 4, and the limit as x goes to 0. So here we have tangent of pi over 4. Well, we know the tangent of pi over 4 is simply 1. And so what we end up with inside is that everything goes to, as x goes to 0, pi times 1, which is simply pi. So secant is well defined at pi, and secant is a continuous function since it's differentiable. And so consequently, I can exchange the secant with the limit. I can say this is equal to secant of the limit as x approaches 0 of what's inside, the e to the x plus pi times the tangent of pi over 4 secant x minus 1. Now we can apply our sum rules and break it up. The limit as x approaches 0 of e to the x is e to the 0, which is 1, plus pi times the limit as x approaches 0 of tangent pi over 4 secant x minus 1. So now e to the 0 is 1. They cancel, and we have the secant of pi times the limit of tangent of this expression. Well, again, let's exchange the limit with the tangent function because tangent is continuous since it's differentiable. So we have tangent of the limit as x approaches 0, pi divided by 4 secant x. And so now our quotient rule for limits says if the denominator limit is non-zero, I have the limit being the quotient of the limit. So pi over 4 secant 0, which is simply pi over 4 as secant of 0 exactly equals 1. So we end up with secant of pi times tangent of pi over 4. Tangent of pi over 4 is 1. And so we end up with secant of pi, which of course is simply 1 over cosine of pi. If it's easier for you to remember the cosine values as opposed to the secant values. Well, we know that cosine 0 is plus 1 and cosine pi is negative 1. So there we have the final answer, negative 1. Let's look at a limit problem involving trig functions. Here I have the limit as t approaches 0 of tangent of the quantity 1 minus sine t over t. Now, one of the things we can notice is since the trig functions are differentiable, that means they're continuous on their domains. And so consequently, since 0 is in the domain of the tangent function, it's continuous at 0. And we know that as t goes to 0, sine t over t goes to 1. And so this is going to 1 minus 1, which is 0. So in effect, we can say we can exchange the tangent with the limit and write tangent of the limit as t approaches 0 of the quantity 1 minus sine t over t, which is the tangent of, well, the limit of 1 is simply 1 minus the limit as t approaches 0 of sine t over t. Well, that limit, of course, is 1. And so we get tangent of 0, which is simply 0. One thing that you should probably notice at this point when it comes to this limit sine t over t, or even tangent t over t, let's look at that just a little more closely in light of our differentiation formulas for trig functions. We know sine of 0 equals 0. So when I'm looking at the limit as t approaches 0 of sine t over t, I can say that's the same as the limit as t approaches 0 of sine of t minus sine of 0. After all, I'm just subtracting nothing. And in the denominator, I'll replace t by t minus 0, which in effect is doing nothing to the denominator. And we recognize this right away as the expression for the derivative of the sine at t equals 0. But our differentiation formula tells us that the derivative of sine is cosine, and so consequently that's cosine of 0, which we know to be 1. So now in this way we can view this limit formula for the limit as t approaches 0 of sine t over t as just being the fact that the derivative of sine is cosine and cosine of 0 is 1. This limit is the limit which gives the derivative of the sine function at 0. The same thing would apply if I were dealing with the tangent function. Let's look at the limit as t approaches 0 of tangent t divided by t. Well, remember, tangent of 0 is 0, so I can do the exact same thing. That's the limit as t approaches 0 of tangent t minus tangent of 0 divided by t minus 0, which is the derivative of the tangent at 0. Well, we know the derivative of the tangent is secant squared, so that's secant squared of 0. Well, secant is 1 over cosine, so cosine 0 being 1 tells us secant 0 is 1, and so that's 1 squared, which is, again, 1. So be aware when you see these simple limit formulas, you can often remember what they are by viewing them as derivatives. We've seen the formulas for differentiating trig functions. Remember, there are 6 basic trig functions. The formulas have a pattern. We have the derivative of sine is cosine, the derivative of tangent is secant squared, the derivative of secant is secant times tangent. So if you can keep that in mind, the derivatives of the cofunctions are obtained just by replacing in each case the functions in the formula with their cofunctions, but putting negative signs in front of the right-hand sides of the formulas. So for instance, the derivative of sine is cosine. That means the derivative of cosine is negative sine. The derivative of tangent is secant squared. So therefore, the derivative of cotangent is negative cosecant squared. The derivative of secant is secant times tangent. So the derivative of cosecant is negative cosecant times cotangent. Well, try to practice with these formulas with a lot of examples, and you'll finally get them down.